Good evening and welcome to the 2021 GIS Day Baton Rouge event. Those of you online with us through WebEx, welcome. We have a nice gathering here in the downtown library, River Center Branch Library. And I'd first like to start this out by thanking the sponsors. My director, Eric Romero, for listening to me about in the middle of the summer when I started talking about GIS Day. And as well as Mary Stein, the assistant director of the Parish Library, for helping promote GIS Day and providing us with these great facilities. In the past, we've held the event at the main library in Goodwood. Of course, last year everything was virtual. So we wanted to give the River Center branch an opportunity to host it here and try this hybrid approach so that folks that can't make it in person can still join us virtually. To start the night out, I just want to real quick give an introduction about what is GIS. Of course, geographic information systems are way more than just a simple map. I'd like to think my colleagues can explain a little bit more about what we do professionally than just making cartographically beautiful maps. Anything location-based, so many things like assets and addresses, it has a location tied to it. That's the heart of GIS. It's what makes this technology different than spreadsheets and so forth, because we can tie location to the individual records. And using that location-based data, we can create applications. It's become easier and easier today with all this web GIS technology to make these applications. Obviously, those applications are what are helping anyone and everyone make better decisions. That's what it comes down to. So I'd like to think as a GIS professional, I'm helping decision makers make better decisions. Our speakers tonight, starting out, I'll introduce Michael Stein. He's going to speak about dropout rates in the state of Louisiana public high schools. Viola is going to speak about basic remote sensing techniques as well as developing flood maps. My colleague David Gisclair is going to talk about the National Oil Spill Database, and then I will close out the event tonight with just a quick presentation about the state of the city parish's GIS program. And then lastly, before we get started with the presentations, I wanted to mention that we have a companion gallery on display at the main library at Goodwood. We've had this installed the last several years, and this year we decided to completely revamp it. It has a brand new theme, some new content, some of the same content, and honestly, it's for all ages. There's information, just anything and everything geography and GIS displayed on this wall. As you walk into the main library there across from the circulation desk, that's where you'll find it. It'll be up until the end of November. And if you can't make it over to the Goodwood Library in person, we created a story map that you can access all the different posters online. And the presentation here has a link to that. All right, so that's my introduction. I'm going to now ask Michael Stein to come up. Michael is a senior GIS analyst who works with me at the Department of Information Services. He recently graduated with his master's degree from the LSU Department of Geography, and he's going to be presenting his findings of his thesis project tonight about dropout rates in Louisiana public high schools. Welcome.
Good evening, everyone. As Warren said, my name is Michael Stein. I'm a GIS analyst in our department. And as we mentioned in the introduction, being a GIS analyst is not just about making maps, although that's often the end result of what we do. Being a GIS analyst is about using data and spatial information to solve problems in the real world. That was my aim for this project for my master's degree. So high school dropout is a significant problem, both locally to us here in Louisiana and nationally. Every year, well over 500,000 American students drop out of high school. Most of them never return to finish their high school studies or get a GED. Most of them go straight to a life of government assistance and unemployment. And even worse than that, many of them become involved in criminal activity. About 75% of crimes committed by high school dropouts in the United States. I certainly didn't know that. That was pretty shocking to me. Louisiana consistently ranks among the highest in the nation regarding high school dropouts, and often we're the very highest in the country. I found in my study that roughly 1 in 9 of all 7th graders in our public schools don't finish the 12th grade. That's about 6,000 students every year that drop out of our schools. And it creates a significant hindrance for our state's economic development. It creates a negative feedback cycle that keeps communities poor. There's already been extensive research done nationally about high school dropout because it is such a significant problem. But most of that research has come in other fields like psychology, economics, and sociology. There's a real lack of research done in GIS. There's a surprising lack of research done locally here in Louisiana, even though it's been such a huge problem in our state. Maybe once a year in our local paper like the Advocate, we might get some very basic numbers of the dropout rates in our schools, but it's nothing more than a cursory look at those numbers. I wanted to do something that was more comprehensive, that could benefit the whole state. So my research questions for this project were, what specific factors correlate with dropout rates in Louisiana? Using national research is a good launching point, but to really understand how the problem is developing in our state, we need to use only local data because there are unique factors in play regarding high schools that don't exist in other parts of the country. And of the factors I'm testing, are there variables that the schools can actually act upon to help reduce dropout rates? That's ultimately the goal, to find those type of factors. Because if we can identify them, we can improve them in the future. And second, I wanted to learn the spatial distribution of dropout rates in the state. It's not enough to just know what the numbers are. Which schools and school systems specifically are struggling with dropout the most in our state? So part one of my project was the statistical analysis of the data set. And at first I wasn't quite sure of what data was available when I first started the project, but I quickly discovered that extensive records are kept on the State Department of Education website, as you can see in that screenshot. Starting in the 2014-15 school year, there are spreadsheets that contain statistics not only about dropout rates, but dozens of other variables as well. It's an enormous repository of information. So it took me 10 months to compile all of that data for the statistical test. My study includes all normal public high schools in the state over a 5-year period from 2014-15 to 2018-19. And normal meaning there are no virtual schools or reform schools, but charter schools are included. And that's very important when we talk about New Orleans. One important caveat, though, is that private schools are not included in the study because it simply is not possible to get enough information that can be cross-compared with the public schools. So to do this analysis, I used the Peterson's correlation test to analyze the relationships between variables. Even though it's a very simple measurement, when you're using a massive amount of data like this, it can tackle that really well and tell us very meaningful insights about what the data, about the data set. Part two of the study was mapping the dropout rates. I did this by splitting the state up into 10 regions. And I created over 100 choropleth maps in ArcGIS Pro. You can view all of them in the full report, but here just 3 on the screen As examples, I mapped the dropout rate for each individual grade 7 through 12 and the average dropout rate for the entire school. The color scheme in the map goes from dark blue to dark red, with blue being the lowest dropout rates and red being the highest. So we want to see as much blue in these maps as possible. So now I'll summarize some of the findings from the correlation tests. Regarding our demographics, Black and Hispanic students are significantly more likely than average to drop out of school, and they tend to do so the most often in the 9th and 10th grades. Whereas white students who drop out of school in Louisiana tend to do that in the 11th and 12th grades. And that matches up with the national statistics regarding these demographics. So that's not too surprising. One interesting thing, though, is that our Native American students in Louisiana are less likely than average to drop out of school, whereas nationally, Native Americans drop out of school at very high rates, especially if they're on a reservation. I think some of my most interesting findings from the study are on this slide. The expense per student actually has a slight positive correlation with dropout rates, meaning on average, the more school spends on a student, the higher the dropout rates of that school are likely to be over the entire state. Also, the disparity in dropout rates between Black students and white students is not related to funding. The same is true for the disparity in dropout rates between male and female students. The correlation tests were very clear on that. Also interesting is the statistics about class sizes. Class sizes of 20 students or less are shown to be ideal for reducing dropout rates, while classes of 27 or more students should be kept to a minimum starting in the 8th grade. If classes stay large, once we enter the 9th grade, we start to see some real negative impacts regarding dropout rate. Likewise, the starting grade of the school as a whole also has a significant positive correlation with the high school dropout rate. So the lower the start grade for that facility, the lower the dropout rate is likely to be. And interestingly, when you break down the individual grades, it seems to be much better to start high school in the 7th grade instead of the 8th or the 9th grades. Now, obviously, we can't make every high school in the state a K through 12 school. That's not feasible. But luckily, it is much more feasible to convert a 9 through 12 school into a 7 through 12 school. And many school systems around the country and around our state are already doing this. I know in a point in Parish, Livonia recently switched from a 9 through 12 to a 7 through 12 school. I think that's a much more realistic approach to addressing this variable. Now, as for the choropleth maps, the overwhelming thing that jumps out at you when you analyze the maps is that dropout in our state is overwhelmingly a problem in the more urban and populated areas of the state. Regardless of all other demographics, rural schools, even in very impoverished areas, tend to have below average dropout rates, whereas almost all the schools in the state that have high dropout rates are in these urban populated areas. And I think by far the best example to emphasize that point is by comparing the Northeast Delta to the North Shore, as you see on the screen. The Northeast Delta is the poorest region of our state and one of the most impoverished regions in the entire country. And yet the dropout rates in those schools are actually lower on average than the North Shore, which is the wealthiest part on average in our state. That was very surprising. Likewise, in East Baton Rouge, Rapides, Tangipahoa, and Jefferson Parish, the dropout rates are extremely high, and the majority of the schools in those parishes all have above average or high dropout rates. So these are major problem areas of concern. Some good news is that the charter school revolution in New Orleans appears to be very successful, not only regarding test scores, but also dropout rates. For those of you unaware, after Hurricane Katrina, basically all the public schools in New Orleans were relinquished by the Orleans Parish School Board and given to local charter organizations. So they're not real true public schools like how we would think of here. They're all charter schools in New Orleans. And by and large, they're doing a very good job at keeping dropout rates low, despite the demographics of New Orleans suggesting that the dropout rate should be very high there. Even some of the largest schools in the city, like Kron and Warren Easton, tend to consistently have low dropout rates. So I think New Orleans is kind of a beacon of hope in the fight against dropout rate. Those charter schools are obviously doing something well. So ultimately, I come away with a more optimistic view of the problem than when I started the project. It's not only socioeconomic factors that affect dropout rate. There are some factors that the schools can actually manage, such as class sizes, that could help in lowering their dropout rates. And you don't need to simply hire more teachers to do that. There are other creative ways, like switching up the schedule, that you could lower the class size. Now, funding and implementing those changes will be another hurdle, but at least it is possible. I've had to condense a 150-page report into a much smaller presentation here. You can access my full report in the LSU Digital Commons at that link on the screen. It includes all of my maps and a link to the master data set where I've compiled all of that data from the repository so you can look through for yourself, use it in your own studies. I'll answer any questions if you all have any. Thanks for listening. Yeah, the 10 regions, I split mostly based on the natural geographic division of the state. So the Shreveport Metro, the Monroe Metro, the River Parishes were their own thing, and so forth. It wasn't based on the school size, but more just kind of the natural boundaries of the MSAs in those areas. And I've been trying to pair similar regions together. There certainly was some arbitrary nature to that, but it is based heavily on the MSA and the way the schools are grouped together naturally. Uh, yeah, the questions he asked was how I define the 10 regions, what characteristics I used to separate the schools. And you can see the map of the 10 regions in my full report online and put it into the slide. But it was mostly based on the MSA. I picked one dominant city in each region, except for the Northeast Delta, because that doesn't have one. And I based it around that. Question.
And I guess you only looked at a certain year's assets, but see correlations, like natural events like hurricanes, dropout rates.
Yeah, so he's asking if I've never seen any correlation between some type of natural events like hurricanes and dropout rates in the data. So the data I worked with only went back to 2014-15. That's the first year that the state reports any detail with this. And I would say overall, no, I didn't notice any major shift at all over time in the dropout rates. They tended to be very consistent across the board, but I would love to go back and look more specifically at, say, the Bayou region during the hurricanes, or last year if I had access to the data with COVID, that would have been a fascinating thing to study, but we didn't have that data yet when I was compiling it. But if I were to do a follow-up project, I'd love to see how COVID affected the dropout rates. Yes. I would have to, he's asking if there's any correlation between more expense per student and a larger class size. I don't have the data set in front of me. I did calculate that. If you send me an email, I can get back to you on that. But off the top of my head, I don't think there was any strong correlation. It certainly wasn't a strong correlation between those two. It was probably a neutral correlation at all. Yes, yes. Yeah. she asked me, why are the dropout rates in the Northeast Delta lower than the North Shore? And I think it's because of the population and that the Northeast region is so rural. That those kids have much less distractions than maybe kids in a more populated area do. And their schools are much smaller. I didn't include the school size in this presentation, but school size also correlated strongly with dropout rates. Across the board, the more populated the schools were, the higher the dropout rates tended to be regardless of all other factors. And I think that's a big part of the reason why it connects so strongly with the dropout rates in urban schools, because of course urban schools tend to be much more populated, 4A and 5A schools, and the much smaller schools out in the country. I don't think there's any schools in the Northeast Delta with more than maybe 600 kids total. Those are very, very small schools out here. Whereas that would be a small school on that also.
Michael, a round of applause. Thank you. All right, so that'll bring us to our next presentation by Mr. Dale Viola. Dale is a career emergency manager and geospatial professional currently working with Stewart Consulting Group. He served over 25 major disaster declarations. We're building decision-making tools for local, federal, and private sector organizations. He is a distinguished fellow and guest speaker at the Institute of Environmental Communications at Loyola University, New Orleans, and vocal advocate for the International Association of Emergency Managers. Dale?
Hello, everyone. Welcome. Thanks for making your way out. Appreciate you coming out on this beautiful night and spending some time with us talking about GIS. My presentation has two parts. The first is talking about something near and dear to my heart, something that I think is very exciting, and that is remote sensing. So remote sensing is a weird kind of turn of phrase, but I think as we get into the presentation, you'll start to get an understanding of what we're going to talk about. Just by a show of hands, who in the audience has used remote sensing tools in their day-to-day? All right, that tells me what I needed to know. And then the second part of the presentation, we're going to talk a little bit about flood mapping, specifically using remotely sensed surfaces and how that in turn makes its way into the flood maps that show the risk to your property and perhaps even its insurability. So I'm going to move pretty fast. I have quite a bit of slides here. It's a little bit about me. You might need to know about that. So one GIS mantra that I do want to stop and talk about is what question are you trying to answer, and will that answer lead to action? So every tool that we talk about in the geospatial realm is talking about taking attribute data and graphing that onto the surface of the Earth and showing the patterns therein. Remote sensing is no different, except we're using a different way of capturing that data and depicting it. So what do a pigeon, a balloon, and an iPhone have in common? It's not a joke, there's actually something in common. They actually helped to change the way that we see the world around us and how we collected data. Remote sensing is fundamentally receiving and interpreting energy from something that's far away and then without having direct contact. So changes in how that energy is emitted, reflected, and absorbed all can change how we perceive it. And those perceptions can be correlated to different attributes about that object that you're trying to observe. Let's put it a little bit more simply. We all have 5 senses, most of us. We actually have 6 if you count equilibrium. So the things that we don't touch directly to experience, so light, sound, smell, those are remote senses. You are inputting, taking in the environment around you to get information about what's going on. So the colors that we see, the temperature that we feel, those can all be remote attributes. So let's talk about a little bit about what a remote sensing item that we might be more familiar with, a camera. A camera does not directly touch the thing that it is imaging, but it does produce a representation of what is out there using visible light. And then in the old days, we put that on film. These days, we use an electronic sensor to capture that information using pixels. Another item that's commonly used for remote sensing, outside of the geospatial space, medical imagery, using magnetic resonance, using X-rays, seeing through things and taking attributes of our bodies that can be correlated to useful medical findings and help with diagnosis. Using laser measuring tools. So whether that's using a laser rangefinder to determine how far a golf ball is, or using a laser ruler to determine how long a wall is, that is using some principles of some universal constants in in physics to help us to determine distance based on something that we're sensing remotely. Another, radar guns for speed. Radar is another form of electromagnetic radiation that we can interpret to determine whether an object is moving farther away or closer to us. Fish finders using sonar, using the vibrations in a medium or a gas or a fluid to determine the density of an object and whether or not it's there. Forward-looking infrared is used by firefighters to determine whether something is hot or not. It's hard to tell whether a door is hot without touching it. Well, obviously, you don't want to touch things in a burning building if you can help it. So what FLIR does is that allows you to see the infrared radiation coming off of a heated object in a visual form. And then this was actually a pretty new thing that I had seen. There's a device on Kickstarter called the Sunscreener, and it is a small UV camera, and it can show you how well you've put on your sunscreen. So it's using a piece of non-visible part of the infrared spectrum, or the electromagnetic spectrum, in the ultraviolet, to show the reflectance of the sunscreen that you're putting on your face. Okay, but I didn't talk about the pigeons. So before we had remote sensing, we really didn't have an idea of how to see the world from the way the birds do. To see it from the top down. We had maps, we had depictions. Those were our best guesses based on the geometry and the observations that we had. Oftentimes we had to take elevation into account, stepping on top of a mountain, climbing a tower, climbing a tree in order to get that vantage point. In places like Louisiana, we don't have a lot of mountains, I don't know if you've noticed. You can climb on the levee, sometimes that helps. But it doesn't give you the top-down view that you might need for something like battle or for urban planning, or to see which way the water's flowing when it's flooding. So humans get creative, and they decided to fill a bladder full of gas and climb inside of a basket attached to it, and to sketch what they saw. And this was kind of the first idea of, okay, let's get above what we can get on a tree, or even the limited elevation we have here in Louisiana, and start to get the ideas around what we can see, what we can do with that information once we have it. How do we change our vantage point? And so this continued until the advent of the camera. And not just, cameras had been around for quite a while, even while the balloons were in development. But then film cameras came around, and it became a lot more portable. So now we're at the balloons and the pigeons. So for a long time, reconnaissance balloons were a primary means of having a vantage point above a battlefield, above a fleet of ships, when surveying a railroad even. There are accounts of all kinds of people climbing into balloons to try and get a better view of things. Balloons are inherently unsafe. They don't have a steering mechanism. They kind of go where the wind goes. So that wasn't ideal. Also, you can strap cameras to all sorts of things, to dogs, to cars, to trains. Somebody even strapped cameras to a pigeon. The last recorded use of a pigeon camera in espionage was in the 70s, so that's a fun fact. So how do we use remote sensing. So let's talk a little bit about elevation. We can use elevation to help determine, answer questions about agriculture. Areas that are lower in a field are going to have more accumulated water after a rainfall than higher areas. So depending on the crop, that will affect your yield. So we can use elevation data to determine or to predict how a field might perform compared to a comparable field in an adjacent area. Deriving building footprints. We can use that same elevation data to determine the ground elevation of an area, as well as the rooftops of a building, and we can use other geospatial techniques to draw polygons that represent those buildings. Well, how is that useful? Whenever we look later on at flood mapping, we can use those footprints to identify risks to those buildings based on where they're actually at and not just based on the parcel boundaries. So we can also use elevation data to be but also to determine things like watershed analysis, running view sheds, whether or not a cell phone tower will reach people on the other side of a ridge line. Those are all things that we can use this for. We use remote sensing for disaster response. This is an aerial photography taken by the NOAA group with the National Weather Service. They, this is after Ida. We can use remote sensing to quickly assess areas that may be cut off from terrestrial ground travel. We can use that to formulate action plans even before we can see the site ourselves and in person. We can also use it to influence how we route logistics or what roads we might avoid in order to move assistance more quickly. Land classification. We can use the reflectance of different surfaces to determine whether or not something is paved, whether or not a field has remained fallow, whether or not a roof coating has been effective at preventing heat loss. We can do a great many things with remote sensing. We can even determine where the heat islands are inside of our fair city. The items that you see in red are the hottest surfaces in this image, this multispectral image of Baton Rouge. You can see Tiger Stadium right down there. So parking lots, turns out, are very, very hot. Blacktop gets very hot in the summer and can contribute to the heat island effect. But we also use it for coastal land loss preservation and for habitat preservation, for identifying areas that are changing over time. We can take a picture, an aerial photograph or a satellite photograph from 10 years ago and compare it to today and see what are the areas that we've improved as far as land use goes and where we've lost land. So there's 7 stages to any type of remote sensing. I'm going to use satellites here because it's kind of the more distance complex. But the same principles apply even if the effect is negligible. You need an emission source. So the first step is something needs to emit energy for you to sense. Whether that is the black body radiation of the Earth, where if all the lights are out, the Earth is still emitting some electromagnetic radiation, it's usually in the form of infrared, that can be seen and observed. Or it's the sun blasting us with light from thousands of miles away, millions of miles, sorry. And that reflecting off of surfaces and us seeing that, or the flash on a camera. These are all emission sources for remote sensing. So then we also look at the effects of radiation in the atmosphere. The atmosphere around us affects how light travels through it. It affects how radio waves transmit around the world. It affects how lasers work and all kinds of different technologies that we use each and every day. And they also affect how remote sensors work. We'll capture all kinds of background radiation when we're trying to capture the thing that we want to answer our question. And there's also the target interaction. So is that surface that we're trying to look at shiny? Is it, does it absorb a type of radiation that we're looking at? How does that change the characteristics? We can take all of the target interactions at different spectrums of, let's say, the electromagnetic spectrum, and we can determine, make basically profiles of that particular material, and we can identify it later using that same technique. And then basically the sensor that you're trying to use captures the radiation that has made its way back to it. And we use that, we transmit that usually by electromagnetic or electrical signals to a reception and processing unit. That can be off-site in the case of a satellite, or it can be on your phone. There is a image processor in your cell phone that takes the light from the sensor and converts it into a usable image. In fact, it even probably does some other smart things to make it more clear, to make text more legible. May even register what's in the photo. All of those things are processing. And then the interpretation and analysis portion. So that can be automated using, say, algorithms or machine learning, but it can also be used by, it can also basically take place with human analysis. And that's, we'll get a little bit more into that. And then that turns into an application, whether that is a raster, which is picture, for lack of a better word, with the pixel values representing some bit of data that we're trying to capture, or other forms such as a visual output. So there's all kinds of different platforms. We talked a little bit about balloons. We're going to leave the pigeons off of this slide. But we also have manned aircraft. We have unmanned aircraft, seacraft, unmanned seacraft, satellites, automobiles, smartphones. I'm leaving the smartphone on there because it's one of the more pronounced changes in how we collect data in our day-to-day work life. Well, this got blown up, so don't worry about it. Basically, each platform has its pros and its cons. Sometimes the text doesn't show up, and that's fine. But we look at resolution. We look at whether or not something is convenient to use. Is it weather dependent? Is it does it capture a wide area or a small area? Is it cost effective? These are all things that we look at when we're checking for a remote sensor's viability. There's also a fun fact. There are these little hash marks, and you'll see them in airports and in a few other places. Get on Google Earth. It's a fun little game to find these. These are actually camera resolution charts. These lines are known lengths and known distances apart, and depending on whether or not you can make them out in an image, determines gives you a good idea of the resolution of that image. So if you can make out the 1 foot pieces, then you have at least a 1 foot resolution. So there's passive and there's active sensors. Passive sensors take just that radiation that's coming naturally off of the surface that you're looking at, and active sensors actively send out energy and then receive it back. That might be like a laser, so for LiDAR, if you're familiar with that. The visible light spectrum, which we're mostly familiar with aerial photography, is only a very small portion of the electromagnetic spectrum. We can see here radio waves, microwaves, infrared, ultraviolet. All of these things affect the kind of information that we can collect based on our target. The speed of light is very important. We won't go deep into that. That's how waves work, and we're back. So let's talk about bands. In the electromagnetic spectrum, there are certain areas of the spectrum that are more useful than others. So our atmosphere and the different gases and compounds that make it up actually block out certain parts of the electromagnetic spectrum and make it less viable to use for performing analysis. We've identified through years of research and very smart people, I say we, royal we, these series of bands that can be used mathematically together to determine viable outcomes and to produce products that can answer questions. These often correspond to very complicated instruments on very expensive satellites or in aircraft. But again, allow us to see things that you wouldn't normally be able to see. So right here we have some leaves that are changing. And in the different bands, in the infrablue band, in these two mathematically divided bands, you're not seeing too much difference. But whenever we subtract the near-infrared red band, or the two mathematical band calculations there, we can identify the bands or the leaves that are not healthy. And we can apply that to a whole forest or a whole crop and determine whether or not a certain species of tree is not getting the care that it needs. Is there a disease outbreak? Is there some other area of concern that we need to be looking at? We can look at current scars, and we can find hidden smoke in the atmosphere using different band combinations. This is a false color where pink has been applied to the near infrared spectrum. So no, the land isn't actually red in this case. But we can also see floodwater. And this is something that's near and dear to my heart as an emergency manager, is when a flood happens, usually it's happening upstream first, and then it will eventually affect downstream communities. If we can tell the volume of the water, if we can observe how far out it goes, we can make assumptions about its volume, about its flow, that can affect downstream communities. So the faster we can get that information and the faster we can answer those questions using remote sensing, the better our response will be. And there's some really cool places to get remote sense data. So are there any questions before I jump into flood mapping? Shoot.
Accurate can we get? And second part, you think AI and machine learning have we been able to improve?
So the question was, we use profiles to make determinations using remote sensing to answer questions and to perform analysis. How accurate can that be? It is as accurate as the data that is going in. It is accurate as the algorithm that is used to process it. So at every stage, there is a margin of error that we have to account for. And it's getting better and better all the time. But depending on, we can make specific species determinations and looking at a whole forest of trees. But we can't quite say whether or not that tree has a certain characteristic, perhaps. It takes a lot of research, takes a lot of time, takes a lot of, but we have a library of these profiles that are being built over time. And then we feed those into things like AI. But again, garbage in, garbage out. You need your best available data in order to have your best available analysis. All right, ready to go to flood mapping? There's no pigeons left. I'm sorry. Let's get into the basics of it, wherever the water wants to go. Second old adage, check your boots before it rains. You don't want to be doing flood mapping and checking your flood insurance policy while it's raining. You want to do that long beforehand. And that's kind of what I'm getting at with this presentation. Flooding is the overflowing of water onto land that is normally dry. I don't know if anybody is from Louisiana. Normally, you don't have a lot of dry land, generally. It's marshy in most places. We're a series of islands connected by bridges if you look at it geographically. So flooding is near and dear to our heart because the little bit of dry land that we have left, we don't want it to get too wet. That's some why flooding is important to talk about. I think we all know that here. Some different types of flooding. We're going to talk a little bit more about riverine flooding, about inland flooding and flash flooding. The other types are important to other parts of coastal Louisiana. I'm going to focus on Baton Rouge today. But there's things that cause flooding in areas that haven't flooded previously. This is something that's a little bit of a sensitive topic. Urbanization, paving of surfaces, and we lose the natural permeability of the soil to capture and detain rainwater. It flows out on the surface and it accumulates and the bad things happen. Same with deforestation, we lose the root structure that keeps a lot of the soil together. Erosive farming techniques, ground subsidence, mineral extraction, all of these things affect either the elevation or the quality of the surface that the water is running across. And all of that changes how it accumulates and where. So there's a lot of very smart people that work very, very hard to make these maps and to make them as practical and as usable as possible. And they are much smarter than me and have a lot more letters after me. So there's lots of different types of flood maps that we can look at. We can look at where it's flooded previously. We can look at the depth of the water in previous floods, where we might think it could get deeper based on different changes in conditions, how it threatens certain communities or certain building types, and how much that might cost. So we have to clearly define our area of interest when we're trying to look at our own flood data. So we want to know how does this going to affect our community? Where does the water want to go? What's it going to carry along with it when it gets there? Does it have a way to get out? How is it going to affect different other parts of the built environment? There's a lot of very important terms that I'm going to skip over for the sake of time. So a little funny thing about water, it wants to flow downhill. This is kind of a pretty simplified view of what a watershed is. Basically, it's an area where that funnels water down out of it. So anything that rainfall that falls in that part of the watershed flows out. Same goes with if you dump a bucket of water on the ground, eventually it will flow out to the sea. This is a cross section of that same watershed where we can see there's a small area called a floodplain. A floodplain is an area that we expect to flood, to have water in it when it normally doesn't, at regular intervals. Those intervals are defined by law, and I won't get into them here. But depending on the area that we're talking about, rainfall can enter and leave a watershed quick or slow. Urbanized areas, water accumulates really, really quickly, and then it can leave really, really quickly. In an unurbanized area, such as farmland, it's a little bit slower moving across, but it also leaves a lot slower. This is a hydrograph where we're looking at the forecast of what the water tank will be in this area. Can anybody tell me if this area is urbanized or unurbanized? It's urbanized. This is in Dallas. Doesn't get much more urban than that. So the concrete, when it rains, it goes from 0 to 60 pretty quick. So we're going to talk a little bit about FEMA flood maps. So this is msc.fema.gov. This is the map service center where if you want to look up your address and see your flood risk based on flood zones, you basically pick your little spot out of the map. And if your area hasn't updated its firms, you get a paper map like this that can be kind of useful. Or you can get a more advanced one that you can do a lot more with. So flood zones depict your risk based on some statistical variables and some insurance variables. Just pay attention to that letter combination and when that was last calculated. But we can use the information we collected earlier to create something called the depth grid. So every area that floods doesn't flood equally across its borders. So whenever we look at the area that floods, whether it floods an inch or 6 inches, it's just showed as one area, but we can delineate using some raster math how deep it's going to get. So we start with an elevated surface detected, in this case with LiDAR, that shows us the height above ground, the ground elevation. And then we can overlay some pretty basic flood depth, how high the water is going to be, and then we can calculate the flood depth at any location, and then take those building footprints and determine what part of a building we expect to flood and how deep, and how much damage that might cause. Bring it all together, that might influence how much insurance you get. If you're only going to have a first floor flood, maybe you change how much content you cover versus if all of your floors will flood. And basically, every flood map is only as good as the last time it was calculated. Things change constantly, and we need to keep an eye on it. So, any questions? Shoot. Is there an area, or is there a map out there that shows the area that flooded May the 17th? I believe that there's actually a map or a depth grid that is currently being developed by the United States Geological Service. I actually have a link to their historical mapper in this slideshow. So if you come see me after, I can get your email address and I can send you that link. Shoot. Yes.
They changed the rules in October.
Yes, they did.
And how do you, is there a new map for that? Or?
So the rules themselves don't determine, the maps themselves don't necessarily determine how much you pay in flood insurance. Those are different things. They do play into each other regulatory under the law. So your risk for flooding in a given year hasn't increased, but they're changing how they're calculating that risk and how that applies to the dollars that you pay. So talk to me afterwards and I'll get you the best resources I can. One online question.
Areas in the world, similar flooding issues that Louisiana is facing currently. Have you seen their watershed maps and how they look compared to Louisiana?
Solution for those.
So yes, actually, I have had the pleasure of traveling to the Netherlands, which is a lot like Louisiana in that it is flat, but they also have over many hundreds of years undertaken many large infrastructure projects to affect their flooding vulnerability and have created an amount of land consonant to its original loss. I'm not sure, based on our current understanding of environmental protection. We value our wetlands a lot, so we're not going to just dump sand in there to make more land for livable. Building flood walls affects all kinds of marine species. It affects how we conduct our daily lives, even here inland. So even Japan had similar struggles in the 50s and 60s in the coastal regions for riverine flooding, and so they also engaged in extensive infrastructure projects at the expense of the natural environment. Though that's a hard line to look at, especially with land loss and livable area and risk. But we're not the only ones that live here. Is basically what it comes down to, and we have to take into account what are we willing to lose versus what are we willing to gain. Are things like infrastructure projects worth the cost to the environment and also financially, and the loss of human life if we don't? So those are all risks that we have to calculate.
Right, we have next up, a colleague of mine, David Gisclair, someone I've known for a while now. He retired from the Louisiana Oil Spill Coordinator's Office, also known as LOSCO. And in his service there, he directed the Technical Assistance Program in the Department of Safety. In this position, David led the way in acquiring statewide GIS data to simultaneously address oil spill legislative mandates. Some of you in the room or online may recall the DVDs that circulated back in the earlier 2000s with hundreds of statewide data sets on them. David's the mastermind behind all that. He was data sharing before data sharing was cool. As I mentioned, David's a colleague and a friend of mine. We both served together on the State GIS Council and have been working actively to further develop the Louisiana spatial data infrastructure, which is a framework for all spatial data interchange between different agencies, public, private, not-for-profit. That introduction, David's going to speak to you next.
Thank you. I'm going to bring you on an interesting tale. What I'm doing here is basically, first, I want to thank Warren and East Baton Rouge Parish for winning one of the free licenses to use Esri software. It made it possible for me to do what I was doing in terms of my research and to present it here today as to what the real situation is. So thank you, Warren. Now, spatially enabling the National Oil Spill Database. What is that all about? What does that mean exactly? Well, basically what it means is we're basically trying to turn a non-spatial database into a spatial. Okay? With that in mind, I'm going to talk about the topics here that we're going to cover. What is the National All-Spill Database? Actually, it's part of the United States Coast Guard. The USCG is the United States Coast Guard. NRC is part of that. Now, let me give you a little bit of history on this so that you can get some kind of idea about what's going on. The NRC is the National Response Center, okay? And what it does, it records every spill that happens in the United States of America, and I'm here to say around the world. There are reports that are coming in from the other side of the planet. So that you know this kind of scope. It was developed for America, but reports are coming in from everywhere. And that brings its own set of challenges, and we'll talk about that. Okay? The National Response Center is the sole point of contact for all oil, chemical, radiological, biological, radiological discharges in the USA. That's a big statement. They're responsible for all of it. Okay? It serves as the communications and operations center for the National Response Team. It also takes terrorist/suspicious activity reports and maritime security breach reports. How do we know that? Because I read them. Suspicious activity next to a refinery. Someone's taking a picture. Is that terrorists that are, trying to get information about the site? Don't know, but they have those reports in the database. It has nothing to do with releases or spills. I'm just saying, the only reason why I'm making this statement, the last item, is because I read it. Okay? NRC all-spill database issues. Okay, the reason why this whole database exists is because of the Exxon Valdez, 1990 Exxon Valdez spill. Once that happened, there was a demand from the environmental community saying, we have to track all of the releases that are going on, not just the big ones. And so the Coast Guard had to scramble to get this database put together in 1990, right? And in doing that, several things happened over the decades. This is the way, and again, as you can see, those of you that are online, this is what it looks like. This was the original schema that was put together. So I'm going to go into a little bit of database technology, and for those of you that don't know it, don't worry about it so much, but you'll get to see what the results are of this. Calls is what I consider to be the master table. When that phone rings that somebody's calling up the NRC about a spill and they pick up that phone, bang, a record is created. That's why I think it's the master table, is because the call also creates an incident commons, an incident details, and an incidents record. Don't forget, spreadsheets are not databases. Spreadsheets have cellular relationships. Databases have table relationships. Okay? So those four tables are all one-to-one. Okay? And I'm going to talk about the issues with that. Notice the other tables are many-to-one. What does that mean? Material involved, many-to-one. Okay? NRC, how can I help you today? We had a gasoline barge and a benzene barge collide, and they're both leaking. One of them gasoline and one of them benzene. Right? So that one call created two releases. So that's one of the first things that I want to get straight here up front, is that the database, the difference between a call and a release is totally different. Okay? So what I'm interested in as a retired all-spill person is in that release. The calls is just an incidental. It's the way to capture the information. Like you were talking about remote sensing, right? You were talking about, how we do it. Well, that call is like a remote sensing device. That call creates a record. It tells me about what's being spilled. Everybody follow me with that? Okay. So now, one of the database issues that came up with this, and it's kind of hard to read here, but up until 2003, I think I cannot prove this, but I believe that the database was Oracle. And in Oracle, when they exported the data, up until 2003, it was in text files. That's what came out, a text file with some kind of delimiter, right? After 2003, we got spreadsheets. Maybe they went to SQL Server, not sure, but if I had to guess, I would guess that they went to SQL and they started exporting it to spreadsheets. But one of the nefarious things that are going on is that every one of these little red boxes, which I can't even hardly read this, and I'm pretty nearsighted, but after 2003, a lot of the reporting callers information went away. What I'm here to tell you is that those red boxes are attributes in that particular year's table. It's no longer there. It's just not there. So everything that we had up until from 1990 to 2003 is in there, and after 2003, it disappeared. I think it had something to do with 9/11, but again, that's just speculation. Okay? So then if you want to maintain the database, you got to punch holes into it. You got to put these attributes back, because SQL doesn't like it too much when you have two different types of, the columns don't match and all this. So there's all issues with that. So you got to punch it back in. It creates what I call a hole, and I'm going to show you what that is. Then in replacement, those yellow boxes is actually something that was added that was not there before 2003. So now you got to go and backfill from 2003 back and create all of these fields that were never populated and were never there. So this is only one particular issue, right? When you look at incident commons, they had all of these flags, weapons of mass destruction flags and all that. And in 2004, if I recall correctly, in 2003, it's hard to read, 2003, it disappeared. They're not there anymore. Gone. Why? No explanation, no metadata to support what just happened, but it's not there anymore. Again, so you got to punch a hole so that you can maintain consistency. Next thing happens. Now, this one was kind of weird. If I recall correctly, this is the river mile markers. In 2000, I can't even read it here. I don't know if you guys can read it, but here, I think around 2003, 4, and 5, it disappeared. The river mile markers are not there. Then they magically reappeared. Now, those river mile markers are really important to try to figure out where a spill is happening. Then you had the same thing. The railroad hotline was there. It disappeared. Now it's back. Go figure. So these are some of the inconsistencies I'm talking about that you have to deal with. This is what I mean by causing holes. When you look at the records up to 2003, there were names and phone numbers, people you could contact and say, wait, what did you mean about this spill? Now, gone. All gone. I don't know why. No explanation, but it's not there. So these are some of the issues that we run into in trying to deal with this. A lot of folks that I know said, I think you're kind of crazy trying to make this into a spatial database, but watch what happens. It gets worse. Okay? Let me see the points here. What happens here, and I don't even know if it's going to show, it's probably going to show, but the bottom line is that the colored squares is the records that are not there, the number of records that don't have the matching one-to-one. You ever tried to add a table that doesn't have an exact match with another table in SQL? It will outbend on you. It's gonna bark at you and say, no, this is not gonna work because I don't have a corresponding record in that one-to-one relationship, right? And as you can see, it's all scattered about except calls. That's why I think the calls is the master table. All right, now you're gonna have to excuse me for a second here. then the coordinate detective comes out. And as a detective, I can tell you, it's very, very difficult to find those little guys. They're hiding all over the database. You have to go and find them. It was supposed to be funny. Because that's what's going on. As you can see here, the coordinates are everywhere except where they're supposed to be. They're in the incident commons description of the incident, they put the lat long. The description of the incident, they put a latitude and a longitude in there. In the incident location, sometimes you have lat long. Sometimes in the incident, street 1 has the lat and street 2 has the long. And you got to go find them because they're reported coordinates. That's the most accurate thing that you have. Everybody follow me? It's like detective work. So then let's take a look at the maps, because now is the real deal, okay? First things first, I'm going to give you this grid. Now, there's a couple of different things that are happening with this database. That's really difficult to understand. You have calls versus releases. As you can see in the spreadsheet up here that I put, there's 689,618 calls in the United States of America over 30 years. That's a lot of calls. There's 925,312 releases. We're cruising almost 1 million releases in the United States of America in 30 years. Guys, follow me on that? So when you look at that, what I tried to do in this part is that, okay, that's what the big picture looks like. Now let's go to Louisiana, okay? Because I only tackled Louisiana because that's the state I work in, right? So I tackle Louisiana and I go look for all the ones that the designation is LA. That's what I call Louisiana, LA plus federal. Now you're going to wonder, what does that mean, plus federal? When you see the maps, you're going to understand. So when you look at it and just look at the state equaling LA, what you get from the calls is 129,000, but the releases are 136,000. Okay. Now, if you take GIS, thank you again, Warren, for the GIS software. I got there with the state. I just cookie cut to the territorial limit of the state. Bang. It drops down to 80,000. See what I'm saying? So all these numbers, and I'm not going to bore you with all these numbers, but all these numbers, I'm going to show you snapshots of it. What does it mean and what does it look like? Okay, this part of the operation that I'm explaining to you here today, to all of you, is that this is part 1. We have to get the spills or the releases, if you will, on the map. Once we get it on the map, you have all this ability to do all these other things, those nice, cool things that the presenter before us was talking about. You can start cookie cutting. You can start looking at cluster analysis. You can start looking at it from different points of view. Okay? For example, pipelines. You know, they say, you know, the pipelines have a lot of spills. Yeah, but there's a lot of backhoes out there. See what I'm saying? So now you can start doing all kinds of spatial analyses with this. Here, this presentation is about getting the points on the map. Okay? And when you look at that and you divide it up into these different types and categories, I was interested in oil and gas. There's the whole hazmat thing. And as you can see in the second line where it says release summary, where I say other hazmat, 233,000. That's all the stuff that's not classified as oil and gas. Okay? When I say oil and gas, that includes diesel, gasoline, all the refined products that are based on oil. And you can see I have all the CRIS codes listed here at the bottom. Right? CRIS codes is, I don't even know what the acronym stands for, but it's basically the codes that they use to tag for materials. Right? There it is, folks. Once you do the coordinate detective work, This is what it looks like. 136,000 plus spills that are attributed to Louisiana. As you can see, it's a lot of them. And they're all over. And I think we're just getting, we're getting this is a bad deal. I mean, I don't know, some of that stuff looks like it's near Texas and some of that stuff looks like it's near Florida, but we get credit for it and I don't like it. Okay? So I go out there with the GIS cookie cutter. Here we go. Click. There you have it. This is what it looks like. It drops down to what, 80,000? Now, I'm going to go off camera because I don't have a pointer and I don't know if can I point on this? I don't know if I can. Yeah, okay. What's going on around here? What's that? Anybody know? Anybody there? Yes? Can we see it on the projecting screen? No, it's only on here. I'm going to walk off camera here for a second. What's that? Port Fourchon. Right. What's happening there? Anybody know? The whole petroleum business out in the Gulf of Mexico is run out of that one spot. In general, right? Generally speaking. That means all the casing. That means all the drill pipe. That means all the drill collars. That means all the tubing. Everything you can possibly imagine is coming out of that port. Okay? Everybody follow me on that? So that's why we're having a lot of spills there, is to support the oil company. Now, up and down the river, you see that blob that kind of snakes around? That's all the refineries and stuff that are working up and down the river and all the chemical processing plants, right? Everybody follow me on that? But that's just looking at it because I kind of know the territory and the terrain, right, of what we're talking about. We haven't done the analytics yet. I'm just looking at the dots on the map and trying to understand. And you know, when you go on this side over here and you see, and I'm going to point, I know it's off camera, but when you point over here, Lake Charles is not immune to that either, right? Lake Charles is not immune to this. There's a lot of chemical processing and there are refineries out there. Everybody following me? So then we go, okay, let's take a different look at it. Let's look at just oil and gas. That's what I was interested in. What's oil and gas? It still looks pretty bad, right? There's still a lot of stuff. The size of the dot, by the way, is relative to the spill. Let me clarify that. 0 to 1 barrel, right? 0 to 42 gallons. Then I go from 1 barrel to 10 barrels. Then I go from 10 to 100. Then I go from 100 to 1,000. Then I go over 1,000, right? That's the size of the dot. That's kind of the graduation of it, okay? There's something else you should know. Natural gas is in millions of cubic feet. 7.48 gallons per cubic foot. I converted everything to gallons to make this work. So the natural gas spills always look big because there's a lot of cubic feet in natural gas. Everybody follow me on that? So, no, this is both oil and natural gas. Hold on, I'm gonna get to it. I will get to it, I promise you. We're just looking at the big picture right now, okay? Oil and gas, 113,000. Right? And it's in my little chart, you know, if you can look in and see that. Take a look in there, 113,000. So then when we cookie cut it to the state oil and gas, it drops down to what, 89, I think? It's hard to read, but yeah. You guys follow me on that? So that's what I mean. LA or LA plus federal. We're getting all of this credit for stuff that's actually not happening in our state. But you can't know that until you map it. No way to know that. Okay, so here we're going to take a look at natural gas. See, the natural gas dots are big. Can't help that. Millions of cubic feet, 7.48 gallons per cubic foot, right? So you got to multiply whatever the cubic feet is times 7.48, so it gives you a lot of gallons, right? Body. Now, next. So that's natural gas in the state. You can see it's still spread out, but it's not too bad. It's only 1,700. So now when we go to crude oil, it's just crude oil now. We're talking about 43,000. But when you go to the state, it's only 18,000. You see what I'm saying? A lot of the spills are happening offshore. That's the whole point of this. And you can see it just in the statistics and the numbers. When you look at gasoline, look at the gasoline spills. You see any out there in the Gulf? Not many. That's gasoline generators, right? That's usually what that's all about. Okay? And that's what it looks like on land, gasoline. That's a lot of that is at the pump, pumping gas and spilling it, right? Look at diesel. With diesel. Anybody care to tell me why is there so many diesel spills offshore? What's going on there? Anybody know? Sorry? That's the fuel that they use. The whole oil industry is run on diesel. Diesel generators, diesel rigs, you know, diesel is the power plants that are used to power up the living quarters and all that. And so it's that transfer from those supply vessels to refuel the tanks on the platforms. A lot of that is what that's all about. Okay, I read 125,000 records. You kind of know, when you kind of get used to seeing what it is. All right, here we go. Diesel on land. There's still a lot of diesel being spilled. You know, overrunning tanks when they're filling up vessels and stuff like that. There's a lot of that going on. All right. So now, unknown. Okay. So now you have somebody flying around a helicopter by 2,500 feet, and for 25 miles, they see this sheen. Man, that must have been 500 gallons that was spilled. It's 1 gallon. It's 3 microns thick, and you can see it for 25 miles. So that's the only rational explanation that can come up. I hadn't done the analytics yet, but for such big numbers of something that's unknown, I think it's just a way overestimation of the issue. All right. And then you still have the sheens on the road, right? It starts raining and the asphalt, it gives up and it creates a sheen and a little spill, but I don't know if that qualifies. All right. Let's go through the summary here real quick. I went through this table and now you get to see what these numbers, you got to see what these numbers mean. The minute you put it on a map, it changes your whole perception about what's out there and what's actually happening. Again, haven't done the analytics. We're just trying to get it on the map. Then we can do the analytics, right? So with that, I'm getting ready to close out here. We're looking at about 4,500 spills a year when you look at Louisiana, LA, which is really Louisiana and offshore. When you look at it from just a state perspective, you're looking at about 2,700 spills per year. Okay, that's all of it. That's everything. Now, when you look at oil and gas, the federal state, the offshore plus on state is about 3,700, and you're looking at the state about 2,000. And that's about right. It's about 2,000 spills a year that we're having in our state when it comes to this whole notion of oil and gas. Everyone follow me on this? And this is just the real raw basic statistics. We haven't analyzed anything yet. I'm just doing the research of trying to get it on the map, right? So the database contains several inconsistencies in summary, but is the only nationwide database tracking environmental releases of oil and chemicals, etc. Right? Requests to meet with the U.S. Coast Guard NRC to resolve or even just try to resolve some of this stuff by email. Real difficult. They don't answer questions. But you know, the military. It's the military. Ever answer really any questions? I don't know. Major questionable assumptions were applied in creating a spatially enabled national all-spill database, and you've got to see it. And everything that I'm showing you that you've seen on the map and those records and tables and mismatches and all that, it's all right there. You can go get it right there. Just go to the NRC website, www.nrc.uscg.mil. Just go take a look. They got that right there on the first front page. Every year you can download the data. Guys, follow me on that? And with that, I'm going to close and say thank you, and I'll take any questions, I guess. I forgot time, Mark. Any questions? Yes, sir. No, 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 no. What we have right now is just the data that's being compiled. There's no analytics tools or any kind of web presence of any of this. Nope, don't have that yet. We're still working on it. There's a lot of work, there's a lot of inconsistencies that has to be resolved, and we have to document how we're resolving it, right? It's a real big issue. Because, you know, it was Exxon, and then it was Mobil over here, and now it's Exxon Mobil, and who is it really? See what I'm saying? How do you resolve that? I understand where you're going, but, you know, there's some thought that has to go into how to resolve that. See what I'm saying? Any other questions? Yes, ma'am. Well, I will say that ultimately, I think we would like to see this in some form online. I will say upfront, for a fee. We spent a lot of time and effort to make this happen, so we have to recover costs concerning that. But ultimately, I'd like to see it online where people could actually query a specific, and we haven't even decided on what the geographic extents that you can query will be and how much it's going to cost. Okay, so there's all kinds of issues in terms of cost and cost recovery and how we would do it. But I will say preliminarily, okay, of what I've seen of the entire nation, this is only a small piece of it. Okay? I am. Yes. Yes. So, you know, with a petroleum engineering degree, a computer science degree, and an MBA, it's taken all of that to actually make this happen, because there are a lot of different disciplinary things that are involved in trying to understand what is the database actually trying to tell me, okay? And do it in a statistical sound manner, if you will. Any other questions? Yes, ma'am. Not that I know of. I mean, the database has been spatially enabled by other people, but they're only enabling the reported coordinates. We're doing all of them. Yes, sir. I'm sorry? I have not talked to the Coast Guard. The question was, is the Coast Guard providing any support for this activity? And the answer is, at this point, no. The bottom line is that I'm sure that we will have a discussion in the future, because having looked at 125 plus thousand records, I can tell you, think about this, everyone, just think about this. Let's back up for 1 second. It goes from 1990 to 2019. I haven't incorporated the 2020 data. And when 2021 is over, you'll have to incorporate that, all right? The database, think about this, is 30 years old. What does that mean in computer science terms? Anybody? Take a shot. What does that mean in computer science terms? Huh? Ancient. Perfect. I will be more specific than that. Computer technology doubles every 3 years. The thing is 10 generations old. So it has some problems. It needs to be corrected. It needs to be updated. Now, whether the Coast Guard will get any money to do that, I don't know. Talking about building back better, I don't know. You know, I'm just saying, me, I'm not too smart. I just kind of look at it and try to figure it out. But ultimately, what should happen is that the database should be drugged forward into a new system that's more modern, where we can just report the incident right in our phone. I don't know why we can't make an all-spill report in this day and age right from our phone, but we can. Cannot do that. no mechanism to do that. Follow me? Was that? Well, I'm just saying that from an environmental standpoint, I can tell you just anecdotally at this point, there's a lot of preventable spills. A lot of preventable. Tankerman puts the diesel hose in the tank on the boat and walks away. Guess what happens? The tank fills up. Guess what happens? It goes in the water. See what I'm saying? Preventable spills. There's quite a few of those kinds of things going on. And it's not that it's costly to do, it just needs to be done. You know what I mean? And so there's, like I said, that comes in the analytics part, right? When you get down to the analytics, we'll be able to zoom into this and figure it out very quickly. Right? Any other questions? Yes, ma'am. Right, and so that's why I'm saying the database design has got to change, because we could get, for example, let me give you just one quick example. I don't want to take too much time, but the bottom line is that all of a sudden, PHMSA, who is the federal pipeline safety entity, right, under the Department of Transportation, what did they do? They made a decision that in a pipeline spill, 48 hours later, you have to have a follow-on report. That was a procedural change. Guess what? Looks like 2 spills. It's really only 1. Okay? A lot of times you have follow-up reports that say, yeah, we said it was 5 gallons, but it's really 50 barrels. It's the same spill. So it's the same incident. So there are real serious issues that have to be addressed in the redesign of this, so that we can get an accurate picture of what's actually happening. Right now, we're just mapping all of the releases, and there may be duplicates at this point. Any other questions? Well, I think it was a thought-provoking conversation, and thank you for your time.
Going to bring us to the final presentation of the night. Yours truly. I'm going to give this to you. Didn't even introduce myself earlier. I'm Warren Kron, the GIS manager for the city parish. I work in the Department of Information Services next door in City Hall. And I'm going to talk to you tonight about the state of the EBRGIS program. Basically, that's a fancy name for our enterprise GIS. I want to just say that the city parish is really running a true enterprise GIS program. We are managing data of all sorts and types and building the tools and applications for every kind of location-based problem that has come about. A wise guy once told me that all governments basically are doing the same thing, offering various services to its citizens, but it's those jurisdictional boundaries that distinguish one government from the next. What's more perfect than using GIS to help distinguish those boundaries and analyze the information? So my group is managing over 4 million records of data. And this includes things like address points, the property boundaries, the sanitary sewer network, all of the stormwater asset data that's recently collected. And all of this data, digital data, is being used in applications for analyzing and to essentially improve the effectiveness and efficiency of city parish operations. And in regards to public safety, our GIS data is the foundation for the parish's 911 system. It was recently implemented a couple years ago to replace a 30-plus-year-old system that did not use any kind of GIS data. Our GIS applications provide a platform for the Baton Rouge Police Department's real-time crime center, where they now have the situational awareness in real time to see what is happening in the city as far as incidents and where their vehicles are. I was told when I first started working with the police department on applications that maps were drawn with dry erase markers on the backs of the trunks of their police units. We sort of raised the bar a little bit for them. And in the real-time crime center, they now have applications to do deep dive analysis into understanding crime and why this persists in our community. As we've been continuing to further implement our parish-wide GIS program, we've always kept citizens and in the forefront of our minds to serve. It's a bit essentially who we are serving. And I say that because we've published over 200 data sets in our open data portals. We've been on the forefront of publishing data for several years now and received many recognitions for this effort. Most recently, we've launched a Citizen Data Academy, expanding on that to provide on-demand videos on how to use our platforms. And then lastly, for this slide, we are sharing our data, our authoritative street and address and jurisdictional boundary data with Esri on a quarterly basis so that they can update their world topographic base maps as well as their world locator services. So when you're typing in your addresses on an Esri map, you're actually using data that's coming from the city of Baton Rouge. I know there's nothing really flashy about this slide here. It might be boring to some of you, but it's really important to me because it's brought the recent infrastructure upgrades that we just finished less than a month ago have brought our program back. I won't say the cutting edge, but at least back to the edge of all the technology. We were a little bit behind. After a long wait and a lot of anticipation, we upgraded both our database as well as our servers. The database we run is Oracle. That's where we store all of our geospatial data. And we rebuilt our 2 ArcGIS servers from scratch with new operating systems and new ArcGIS server software. These 2 upgrades enabled us to take full advantage of all the latest technology and new capabilities from the ArcGIS platform. And these include improving the performance of our web services that are used in all of our applications and data sharing. And then also for the desktop users, they're now able to run the most current versions of their professional software. A couple notes as well, as far as infrastructure goes, we recently finished work with the Baton Rouge Airport, who surprisingly has had an ArcGIS online organization site for quite a while. And we took their content and migrated it into the city's ArcGIS online organization just to consolidate, combine resources. And then lastly, just a little note, we're working internally with our programming team to help us document all this data, all these applications, all of these web services that we are maintaining. A lot of times it's up here. But not only to just document them, but how they relate with one another. So when my coworker Justin wants to make a change to a layer schema, what is that going to mess up, right? So we're going to have a way to check on that before change the column name to something more friendly or whatever. Next slide here that I want to speak to is about supporting all of the city parish departments. This is a day-to-day, ongoing, routine job that all of our analysts do. We'll get calls, emails, anything. Users and other departments who are reaching out to the GIS team asking for assistance. It might be just a quick and dirty vicinity map that they need. It might be some complicated spatial query. Our analysts are always ready to help these users. I've got a series of screenshots from different applications that have been either enhanced or created this past year. Starting with this one here that you see displaying the structural damage assessments after Hurricane Ida. I'm going to give a shout out to the Department of Development's director who took it upon herself to build a Survey 123 application or a form. Didn't even tell me about it. I usually would get upset about that, but it worked. And I didn't have to fix it. All I had to do was take the data and configure the dashboard. And the dashboard went on display in our Emergency Operations Center so that everybody there, including Mayor Broom, could see assessments coming in real time. It was really wonderful. The second dashboard that I'm displaying here is all of the debris piles as a result of Hurricane Ida across the parish. We've had a collector app for several years now that our environmental services inspectors go out and use to collect this kind of information. And I've never seen them work this rapidly to cover the whole parish with so many debris piles. There was over 13,000 that they surveyed in about 3 days. And of course, this information was being collected just a couple days after Ida hit, and it was used to inform the debris contractors to go around and which parts of the parish they needed to focus more on to get debris removed. So again, the dashboard was configured, displayed in the EOC, and the dots were just popping up, every minute it would refresh. Third part of the this slide deals with Department of Maintenance. We're actually using GIS to assist them, and it starts with documenting everything that's up here, and these guys that are constantly out in the field dealing with mowing, drainage, herbicide spraying. They used to have, I had them in my office, just handwritten descriptions of areas that they spray or mow or something. And then they got to Excel, and my coworker back here, Allison, took that data from Excel, just written descriptions, and digitized that into these features that now they can visualize what it is that they're supposed to be doing. And when the next person retires, all the information just doesn't walk out of the door now. So the map you're seeing is all the interstate right-of-ways. We've mapped those in the mow frequency, so it's either bi-weekly or monthly. And of course, this work has been contracted out, and a reference to this map, this web map, was used in the bid documents. And the company that was awarded the mow contracts, obviously they used this data to figure out how much, by acre, how much it was going to cost. And now they won the job, and now they use it just to know where it is that they have to send their folks out to mow grass. We did the exact same process for herbicide spraying. And again, the contractors, they're not used to this kind of information being at their hands when they work for cities. They're very pleased. This application is something I'm really excited about. And it won't be long before we're able to actually share this with the public. This was built for the Department of Transportation and Drainage so that they could, again, get away from Excel. What you're seeing is a dashboard with a bunch of color-coded line segments. Those are all the city parish-owned streets in the parish. And they've used with ArcGIS Quick Capture, driving down the street, and they rate the condition of the pavement from 1 to 10. And this, we didn't make the rating up. This is something the state of Michigan actually developed years ago called the PASSER rating system. The Quick Capture app has, a little icon of what a 1 compared to a 10 would look like. I don't even think there are any 10. A 10 would have to be paved yesterday around here. But anyway, it takes about a year to drive every street and assess them. And now we have a holistic view of the condition of all of our pavement in the parish. And the the manager or the supervisor of the road rehab section uses this now on a daily basis because he gets a lot of calls from councilmen and concerned citizens that my street needs to be paved. And he has at his fingertips an app like this to just look up and see what those streets were rated. And he can kind of give them a really quick answer on how soon their streets in their neighborhood will be repaved. So it's a data-driven process at his fingertips whenever he needs it. And then lastly, data that has been mentioned a couple times related to the Stormwater Master Plan. Again, this is another project under transportation and drainage. We're in year 2 of this master plan. In the first year and a half, the HNTB was the company that went out, had their field crews collecting data, collected over 60,000 catch basins and the conveyances that connect each one to drain the city. That data went through a lot of QA and eventually was delivered to the city. Now my team is managing this information as well on a regular basis. Whenever a new subdivision plat is recorded, we update it. The great thing about this data collection project is that when they popped the lids off of each catch basin, they took a 360-degree camera, put it down there, and got a conditional assessment. It's the first time we ever had that. It's the first time we really had digital data for drainage. Honestly, what we had before was unusable. So now our maintenance crews are able to be more proactive in cleaning out drains instead of waiting for the 311 calls and the citizens to be, angry. So this is, again, another game changer for their department. All right, so moving along, I wanted to mention a few integration projects. Some of you might not be aware that our GIS is providing the authoritative data for several third-party systems that are critical to the operations of city parish government. For example, the Red Stick 311 system. When you submit your citizen service request, there are several web services that are connected to that third-party system that gather information like what subdivision are you in, and the street, is it owned by the city or is it a private street, which council district, so forth. So we're adding value to what would just generally be a complaint, if you will. Right? I mentioned this earlier, but our new 911 computer-aided dispatch system, the foundation of that system is our GIS data, the street address points, the street centerline data, all the response area boundaries, like for fire response, for EMS response, for police, the sheriff. Now the 2 universities are about to come online with our 911 system. So it's very complicated. When there's an annexation, it changes everything in the 911 system. Ask Justin, it's a real pain for us, but somebody's got to keep track of that because it matters on who's going to respond to that incident located at, on that street. And we have to get them there as quick as possible, obviously. And then lastly, the building permit system, My Permit Now. And actually, this integration has been for over 10 years now. It was one of the first that we integrated. When the building permit is pulled, they have to do an address verification that uses our locator service, make sure that the address exists. If it doesn't, we're getting a phone call. And when it verifies, it then queries our property database and pulls information like the zoning, the land use code, the flood zone, flood hazard area zone. I think there's about 12 or 14 different attributes that it pulls out of GIS and applies it automatically for the permit taker so that they don't have to go look up that information themselves. It's done automatically. I mentioned earlier, we're always thinking about our end users, especially the citizens. All this is done with tax dollars, and this is your citizens' data. They need to come along as as our technology advances and our applications develop, the community needs to come along with us. There's a slide, I used to use it a lot. There's a maturity path, if you will, where you're sustaining two-way communication or collaboration really between you, the local government, and the citizens. So community engagement, this is a fine example of that, hosting a GIS Day event every year. We also do an Open Data Day event in March. But making sure everyone has access to all this data and the tools, citizens and businesses included. So there was a low-hanging fruit item of ours that we've just been putting off for years now to create a catalog of all our open data. We probably had it on a spreadsheet somewhere, but it wasn't available to the masses. So Eric came up with the name of it, the data set of data sets. That was a genius. And it's a catalog of all our open data, including everything in Open Data BR and EBRGIS Open Data. And there's over 200 data sets in this. It's basically in a tabular format in the Open Data BR portal. You can go there and there's a little description of each, a small amount of metadata for each layer or table with links to how to get to it. So I encourage you all to look that up. And then the Citizen Data Academy, we had an idea last year because of COVID regulations and so forth. We couldn't have events like this. We were used to going out in council district town hall meetings and being invited to speak, and we would talk about all this. So since we couldn't, we thought, well, why don't we just do something virtual? So we had 3 webinars last fall. It started with just an intro, intermediate, and advanced, and they were successful. So of course, you do something once, you got to keep doing it. This year we thought, all right, what are we going to do now? And the idea was to put out on-demand type videos, very specific focus on an app or a data set or how to run a query in GIS, how to export a data set from Open Data BR. So there's now the Citizen Data Academy on demand, and it's split up in 4 modules. We've completed modules 1 and 2, the introduction, the open data talk. We have, these are 3 minutes, maybe 9 minutes the longest. And we talk about our transparency initiatives, overview how to navigate the Open Data BR site and the EBRGIS portal, how to, like I mentioned, how to filter, how to sort, all these kind of basic things. Module 2 is focused on community planning. So apps like our land development application search tool, where you can go in and see the Planning Commission's monthly cases. My government services, so that you can see, where's my nearest school district, or my nearest school, where do I vote, these kind of things. Module 3 is almost done. I think we might have it ready by the end of the month. Living in Baton Rouge, and these we have a video on how to navigate our story maps. There's drawing a blank, but there's other apps in this this module as well that just focus on being a resident of East Baton Rouge Parish. And then module 4, lastly, are things specific to city parish government, such as Open Budget BR, Open Checkbook, apps like this that are about the functions of city government. So you can get to this site from the brla.gov/data academy. Just type that in, and you'll see the on-demand Citizen Data Academy on-demand link there. So this is my last slide, and I wanted to speak quickly about innovation. And everything I've shared with you tonight are really just a glimpse into what we're doing down in the confines of B2 level of City Hall. There's no light. It's very dark. And just on a personal note, I'm very grateful to work with the 8 analysts in my group who are all very talented and come from different backgrounds and education. the thing about them is that they're all dedicated and they really love GIS, and that's why they keep coming to work every day, and we're able to do the great things that we're doing. And from all this work, there has been innovation, sometimes because of failure, sometimes because of being in the EOC, not sleeping for a day, and things just happen, and you're like, oh yeah, that would be great. So we're really truly trying to improve the life of citizens here in East Baton Rouge Parish. That's what it comes down to. But over less than a decade now, Baton Rouge, I believe, has truly been transforming itself into a digital city. And I say this because every day, more and more, we're realizing it, and it's evidenced by recognition that we're receiving. This summer, What Works Cities gave us a silver level certification. We were one of like 30 cities or so that were awarded this past summer. And when I tell you they did a thorough review of everything that we claim to do as far as being a data-driven city, they really graded us hard. We still have, you can go to gold and platinum. So we got work to do. But it's really nice being recognized. And then just Tuesday, yesterday, we were recognized by the Center for Digital Government and received the 7th place ranking among mid-sized cities in the United States of America. Cities like Augusta, Georgia, Fort Collins, Colorado, Norfolk, Virginia, Bellevue, Washington. We're ranking right there with them. And this is for the 7th year in a row we've been ranked in the top 10. It's nice to, like I said, to be recognized by your peers. Maybe one day we'll finally make it to #1, Big E. I just have one last thing that I'm going to leave you all with. Before I do that, are there any questions about my presentation that I can answer? Yes.
What city, sir?
Actually, they did, yeah. So the question is, in the What Works Cities certification, did they give us recommendations on what we could improve to reach their next level of certification? Eric, help me. There was a lot about evaluating yourself. Yeah.
So we have a very strong open data and transparency program. So we scored, I want to say that we scored a perfect score there. Where we were lacking was the performance management in using that data to make decisions within city parish. So we're looking at using the data now for contracting purposes, grading vendors to see how they're performing, performance metrics, those type of things. Warren mentioned the herbicide. It was the Herbicide Rfp. So using data in that capacity so that the vendors, as they're applying for a contract or they're responding to an RFP, they can make a better decision and a more accurate decision as to what it's going to cost the city for that service. So we don't have to go back and do a change order because when they were looking at the proposal, they didn't understand that it was both sides of I-10 that they had to cut or spray or something to that effect. So it's those areas which we knew we were lacking. They identified it. They called us out on it. So that's the part that we're still we're working towards that.
Any other questions? The question is, are there other parishes in this state that have come, talk to us for ideas and, sharing thoughts, right? So Yes. I was just in the back of the room talking to Anthony Summers. He works West Baton Rouge Parish. So, the GIS communities, there's not a lot of us, so we do talk a lot. Actually, too, I'm gonna throw this out. Esri created a regional group, South Central Louisiana Regional Group, and they hold meetings twice a year, or every quarter or so, and there's been some good idea exchange there. The State GIS Council meets once a month, third Thursday. There's a lot of ideas talked about around that forum. And, again, West Baton Rouge Parish assessor came over to visit just a month ago, to talk about imagery solutions. So yeah, there's a lot of collaboration.
Yeah. So also want to say that we're always looking to our peers as well. So we started the open data program. So GIS, and Warren didn't cover this, has been 27 years. We can map it back that far. So that program has matured over a fair amount of time. The open data program, we started in 2014, I think. And that first 6 months was just us reaching out to other municipalities that were leaders in the transparency space. And we didn't look at, okay, who's a comparable size to Baton Rouge? We were looking, we spoke to New York, we spoke to Raleigh, we spoke to San Francisco, a couple other folks that have drawn blank on now, but it was very useful to hear their successes and also the things that we needed to watch out for. So we didn't make the same mistakes that they did. And we're always willing to, if another municipality is contacting us, how did you ramp up your open data program? We get a lot of that as well. Or how we're doing things in GIS, we're always willing to help. Sometimes at the political level, it may not seem that the municipalities are really trying to help each other, but internally we very much are, because we're all may not have exactly the same problems, but we have a lot of the similar problems. And if it's something that we can help somebody with, we'll do that. And of course, if we're stuck, we're reaching out to folks as well to see how best to handle.
Yes. Yeah, we have. Oh, sorry. So the question is, what support or services we're offering from our GIS section to the recycling department? Of course, we map the pickup zones, which day, that's the basis there. We provide that information. Yeah, that's not in any data or something that I have, but I believe they do. Yeah, they pick up just about everything in the recycling carts. That's right. Yeah, we were talking to them a while back now. They collect data about how the tonnage, I believe it is, that they pick up for each one of those that you just described, and report that. Right now, it's just like a PDF document online, but we wanted to pull it into Open Data VR so you can do some sort of analysis with it. But it wouldn't have location tied to it so much. It would just be in bulk. Oh yeah, they have a long-standing history of recycling in East Baton Rouge. Anybody else? Okay. Well, before you leave, I'm going to leave you with some inspiration. I hope that the program tonight has expanded some of your knowledge about not only GIS but open data too. This video that I'm going to play comes from Esri's GIS Day website. Put this together.
It's all happened here. Everything we've ever known, done, loved, took place on this drifting, spinning ball that's our home. It's where we learned to provide, nurture, protect, thrive. And yet,
wildfires are scorching the West Coast, leaving behind a path of death and destruction.
Inches of rain this morning.
The waters keep rising, and according to the National Weather Service,
our very success now threatens our future. Today, our greatest challenge is to learn how to grow while sustaining what sustains us. Your understanding, your science, your work are the solution. You have the power to see patterns and relationships and show us how everything and everyone are connected. You have the power to transform how we produce and consume, build and maintain, unite and strengthen, heal and nurture. You can help us see that we can no longer live apart from nature, but must live as part of it. Today, geography matters more than ever. The geographic approach, your work, and the billions of maps you make are essential for creating a more sustainable future.